Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Multitenancy refers to an architecture where multiple customers or tenants share the same physical infrastructure while maintaining logical isolation between their environments. From applications to storage to network segments, multitenancy ensures that each tenant experiences the service as though it were dedicated entirely to them. Even though the underlying resources are shared, this approach enables cloud providers to scale efficiently, optimize resource usage, and serve thousands of customers securely and reliably. The Network Plus exam includes multi-tenancy in both cloud architecture and security domains. You may be asked to recognize how resources are separated, identify risks of tenant crossover, or understand how access controls work within shared environments. Exam scenarios often present situations where services, users, or data must remain isolated in multi-tenant systems, requiring you to evaluate which mechanisms or technologies apply. A clear understanding of how multi-natification works and how it's enforced helps ensure you're ready for both the test and practical implementations. At its core, multi-tenancy allows one cloud infrastructure to serve many users. A single set of physical servers, storage, and networking gear can be divided logically into many separate customer environments. Each tenant sees their environment as independent and isolated, even though they are accessing shared resources. This is a defining feature of software-as-a-service platforms, and is also used in public infrastructure and platform-as-a-service offerings. Multitenancy is what allows providers to deliver scalable, on-demand services at an affordable cost. The benefits of multitenancy start with cost efficiency. By allowing many customers to share the same infrastructure, providers reduce hardware, power, and management expenses. This efficiency allows for lower subscription prices and improved scalability. Multitenancy also supports rapid deployment. Since resources are pre-configured and allocated dynamically, new users can be onboarded quickly without provisioning new hardware. Service delivery is streamlined, and upgrades or patches applied by the provider benefit all tenants at once, reducing downtime and maintenance overhead. Security in a multi-tenant environment requires special consideration. With multiple tenants accessing shared systems, it's essential to prevent data leakage and unauthorized access across tenant boundaries. If one tenant were able to access another's data or interfere with their workloads, the consequences could be severe. Additionally, resource contention, where one tenant's activity impacts the performance of others, must be minimized. Proper access controls, isolation mechanisms, and monitoring are all necessary to maintain a secure and fair environment. Logical separation is the key to keeping tenants isolated within a shared infrastructure. Hypervisors are used to create virtual machines that operate independently, each with their own memory and processing resources. For network isolation, virtual local area networks, or VLANs, and virtual private clouds, or VPCs, create segmented traffic zones that keep data from leaking between tenants. At the application layer, tenant-specific access controls prevent users from retrieving or modifying data that belongs to other organizations. These separation techniques are critical for security and are directly tested on the exam. Role-based access control, or RBAC, is a method used to restrict what actions users can perform within a tenant's environment. Each user is assigned a role, such as administrator, auditor, or support technician, with specific permissions tied to that role. These permissions determine which resources the user can access, what changes they can make, and how they can interact with the system. RBAC is enforced both at the platform level, by the cloud provider, and at the application level, where custom roles may be defined. This layered approach ensures access is limited by need and by responsibility. Tenant identity management plays a crucial role in maintaining secure separation. Most multi-tenant platforms maintain a separate user directory for each tenant. These directories can integrate with identity providers through federation or support single sign-on, allowing organizations to authenticate users using their own systems. This allows each tenant to control their user accounts, passwords, and authentication flows without exposing them to other tenants. This independence is vital for compliance with data privacy regulations and for maintaining organizational security policies. Auditing and monitoring are critical in multi-tenant environments to ensure accountability and compliance. Each tenant's activity should be tracked separately, with logs that capture user actions, access attempts, and configuration changes. These logs are often used for compliance audits, incident response, and performance tuning. The platform must be able to detect and alert on any cross-tenant access attempts, whether accidental or malicious. By maintaining separate logs per tenant, providers can ensure that each customer has a clear view of their environment without exposing information about others. Shared resources such as CPUs, memory, and disk storage are managed using fair allocation mechanisms. The system monitors usage and ensures that no tenant consumes an unfair share of the underlying resources. Resource throttling may be used to limit bandwidth or compute cycles during periods of high demand, helping prevent one tenant from affecting others. This fairness is important not only for user satisfaction, but also for maintaining performance guarantees or service-level agreements that providers offer to tenants. Network-level isolation is enforced through technologies like virtual firewalls, private IP address spaces, and custom routing tables. Each tenant's environment is assigned its own subnets and routing configurations, ensuring traffic stays within the appropriate boundaries. Virtual firewalls apply traffic rules based on tenant policies, allowing administrators to control inbound and outbound flows, network access control lists, or ACLS, and security groups define additional rules for segmenting traffic. This network-level separation forms a key part of a defense in-depth strategy. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Tenant data encryption is one of the most essential safeguards in multi-tenant environments. To prevent unauthorized access, cloud providers encrypt data at rest using tenant-specific encryption keys. This ensures that even if a storage device is compromised, the attacker cannot decrypt the data without the correct key. Backups are also encrypted per tenant to maintain separation and compliance. In addition to storage encryption, data in transit is protected using TLS protocols, which secure communication between client devices and cloud services. These measures work together to uphold confidentiality across shared infrastructure. Application Programming Interfaces, or APIs, are often shared across tenants, but they are carefully scoped to restrict access. Each tenant interacts with the platform through its own isolated API credentials, such as keys or tokens. These credentials are used to enforce tenant boundaries, ensuring that one tenant cannot access or modify another's data. Rate limiting also helps prevent abuse of API resources by limiting how many requests each tenant can make. Combined with access auditing, these controls support secure and predictable service consumption in multi-tenant platforms. In software-as-a-service environments, multi-tenancy is implemented through a shared code base that serves multiple customers. While the application is the same for all tenants, the data and user experiences are isolated. This is accomplished through techniques like database partitioning, where each tenant's data is stored in a separate schema or table. Alternatively, row-level access controls enforce separation within a shared database. The application dynamically applies tenant-specific logic to restrict what each user can see or do. This structure is invisible to the end user, but essential to secure cloud operations. Compliance requirements become more complex in multi-tenant environments. Regulations such as GDPR, HIPAA, and PCI DSS may apply differently to each tenant, depending on the type of data they store. Cloud providers must ensure that their platform supports tenant-specific access controls, encryption, and audit logs. Tenants may also require logical separation of regulated workloads to meet legal requirements. Supporting compliance in a multi-tenant model requires coordination between the provider and the customer, with clear documentation of shared responsibilities. Incident response procedures in multi-tenant environments must ensure containment within the affected tenant's environment. If a security breach or system failure occurs, the response team must isolate the impact and verify that no data has been exposed to other tenants. Alerts should be generated for affected parties only, and investigation logs must be scoped appropriately. This tenant-specific response is crucial for maintaining trust and avoiding cross-tenant exposure. Providers often use automated containment tools and segmented visibility to support fast and effective resolution. Administrative access must be tightly controlled in multi-tenant architectures. Cloud providers typically assign separate administrative roles for each tenant, ensuring that tenant admins can only manage their own environments. Provider-side access is limited, audited, and subject to least privileged principles. Some platforms use just-in-time access models where administrators receive time-limited credentials that expire after use. This reduces the window of opportunity for abuse and supports accountability. All administrative actions should be logged and reviewed regularly to maintain transparency and meet compliance expectations. Each tenant in a multi-tenant cloud platform may grow at a different rate, requiring the underlying architecture to support independent scalability. Resource quotas are implemented to prevent one tenant from monopolizing compute, network, or storage capacity. These quotas can be adjusted as needed to accommodate growth. Horizontal scaling, adding more virtual machines, containers, or application instances, must occur without impacting other tenants. This flexibility ensures that providers can deliver responsive service to all tenants while preserving system stability and fairness. The Network Plus exam may include questions that focus on isolation techniques, such as VLANs, virtual private clouds, or role-based access. You might be asked to identify what prevents data leaks between tenants, what mechanisms enforce per-tenant access, or how shared resources are managed fairly. Other questions may involve applying security policies to multi-tenant environments or distinguishing between shared and dedicated services. Understanding how multi-tenancy works at the infrastructure, network, and application layers is crucial to answering these questions correctly. Multi-tenancy enables cloud platforms to serve multiple customers efficiently while maintaining strong boundaries between them. It relies on a combination of encryption, access controls, logical isolation, and shared resource management to keep each tenant secure and independent. From identity management to incident response, every layer of the system must be designed with separation in mind. A deep understanding of these concepts helps you evaluate cloud environments, protect sensitive data, and succeed on the Network Plus exam. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.